Well, we've done addition and we've done subtraction, so we're going to need to look at the other operations we have, which is multiplying. And its inverse property, division, multiplying and dividing integers. And so I guess we can start with just what we thought of as multiplication in the first place. Let me add one more here. When I had multiple additions, I could count up how many times I was adding and turn that into a multiplication. And so we kind of want to see how that looks. So I could say if I start with 3, that's 1 times 3. And if I move up to 3 plus 3, that's 2 times 3. And 3 plus 3 plus 3 is 3 times 3. And so on. Well, I have a pattern going here. And so let's kind of look at that pattern backwards and forwards. So if let's start with 3 times 3. And I have 9. 2 times 3. Count down here. And I have 6. I've subtracted 3 from these, right? So if I undo a multiplication, but I do it by the additions, I start subtracting downwards. So 1 times 3 is 3. I've subtracted 3 down to here. 0 times 3 is 0. Subtracted 3 to get down to here. Well, I guess I could keep going since I now have positional numbers, right? Before I didn't have negative numbers, but now I have negative numbers. And so I guess I would just subtract 3, which would bring me to negative 3. Negative 2 times 3 would give me negative 6. And negative 3 times 3 would give me negative 9. And so we can kind of develop by this like descending pattern or undoing these additions as of a way of working with negative multiplications. Well, this also happens if we make the number that we're going to look with negative. So let's, oops, my slider slid. There we go. So let's work on another set of numbers. 2 times negative 5. So I've come down twice. Negative 5, so I'm at negative 10. 1 times negative 5 is negative 5. And 0, anything times 0 is 0. So if I do negative 1 times negative 5, well, I've added 5, I've added 5, so I'll add 5. And negative 2 times negative 5 equals 10. And there's a subtle pattern in here if we look at the signs. And what we notice is if I multiply two numbers with the same sign, my answer is positive. Right. Here I had two numbers with the same sign. I got a positive answer. Scroll back up here. I had two numbers with the same sign. I got a positive answer. So then if I multiply, if I, we, whichever way we want to say that, if we multiply two numbers with opposite signs, my answer will be negative. And as we've talked about, mathematics is looking for patterns. And so here I have two different signs, and I get a negative number. Here I have two different signs, and I get a negative number. This is the pattern we can apply to multiplications. So 2 times 4 has the same sign, so I get 8. Negative 2 times 4, well, I'm just going to multiply 2 times 4, which is 8. And I want to look at my signs. I've got different signs, so it's negative. 2 times negative 4, well, 2 times 4 is 8. I look at my signs. They're different, so it's negative. And negative 2 times negative 4, well, 2 times 4 is 8. And I look at the signs, and I've got two of the same signs, so it's positive. I like the way your book does this. It looks at just the signs. It says a positive times a positive equals a positive. A negative times a negative equals a positive. A negative times a positive will be negative. And a positive times a negative will be negative. Well, this really comes into advantage, or gives us an advantage, when looking at multiple multiplications more than 2. We can think about the signs as a separate entity. And I go, well, I'm going to have a positive times a negative. That's going to give me a negative answer. And a negative times a negative will give me positive. Or I can kind of think about it coming in pairs. I have a pair of negative numbers, so they'll turn to positive. And so I can look at this as being 8 times 6, or 8 times negative 6 is negative 48, times negative 2 is positive 96. Negative 9 times negative 2 times negative 1. Negative 9 times negative 2, same sign, so that's 18, times negative 1, different signs, so that's negative 18. And notice I've had an odd number of negative signs. My answer is negative. So negative times a negative will give me a positive, so that's 12. Then a positive times a negative will give me a negative. And a negative times a negative will give me a positive. Or I could look back and I have an even number of negative signs in the multiplication. So there's a couple different ways we can piece together the parts. Well, the counting up of signs helps really well when we do exponents. Let me clear this out. This would be the point that we were in class. I'd be erasing the blackboard because I had filled it up. So if I have a negative number to the power of 4, that's the same as 4 multiplications. Well, I have an even amount of negative signs, so this is going to be a positive answer. So we know we're going to get a positive answer, so we can go negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. And a negative times a negative is positive, so I get positive 16. But we can tell that because the exponent is going to tell me that I'm going to have this 4 times. Now, a thing we want to note, though, and this is really important with powers, is all my alarms are going off. The thing with powers is they're attached immediately to the number they're in. And so without the parentheses, this negative sign is not attached to the power. So this is like negative of 2 to the 4th. We do the 2 to the 4th first. And so we get 16 or negative 16. Watch this. This comes up a lot in the problems, and it's a notation thing to get used to. This negative sign is not attached to the 2 because of the power. And so you do the exponent bit first and then put the negative. If I want to attach it, I put it in parentheses. That means if I have a negative to an odd power, a negative integer to an odd power, well, that's going to be 3 negative signs. So I know my answer is going to be negative. And so in this case, negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. But by looking at the exponent attached to this negative and seeing it was odd, I knew my answer would be odd. It's a good way of double checking yourself. Well, if we can multiply, then we can divide. And so 6 divided by 2 equals 3. Negative 6 divided by 2 equals negative 3. And we want to think about if I'm doing this division, then to check my answer, I can go backwards. 3 times 2 gives me 6. Negative 3, well, negative times a positive, gives me negative 6. And so division works out that it undoes the multiplication. And so all of the possible 6 divided by negative 2 equals negative 3. If we go backwards, a negative times a negative gives me a positive. And negative 6 divided by negative 2 equals 3. If I go backwards, 3 times negative 2 gives me negative 6. And what's happening here is I have the same signs, I get positive. I have different signs in my division, I get negative. I have different signs in my division, I get negative. I have the same signs in my division, I get positive. And so we can say the quotient of two numbers with the same sign is positive, and the quotient of two numbers with different signs is negative. Again, using the notation that your book has, we can think of a positive divided by a positive is positive. A negative divided by a negative is positive. Positive divided by a negative is negative. And a negative divided by a positive is negative. Thing to watch for: 0 divided by negative 7 is 0. 0 divided by anything is 0. But negative 8 divided by 0 is still undefined. We don't know what it means to take something and put it into 0 parts. And a neat way this comes out is we can look at an example of loss. So if Nordstrom loses $400 on 7 days in a row, how much did they lose? Well, I'm having the same thing happening 7 times. And because this is a loss, we can think of it as a negative number. And so we can say 7 times negative 400 is equal to, let's see, I'm going to have 2 zeros. And then 7 times 4 is 28. And a negative times a positive. And so we can say that they lost $2,800. And the negative sign tells me if it's a loss or a gain. And so addition and subtraction have sign rules, and we can change subtractions into additions by using the idea of the opposites. Multiplication and division have a sign rule where we look for pairs. And if we have a pair of the same sign, it will be positive. If we have odd number of signs, odd number of negative signs, then it's going to be negative. And so we can kind of cluster what our answers will be based off of how many signs there are in the multiplication or division.